Hey guys, welcome to another video. So today we'll continue on with the nice question series in the advanced syllabus. Today's question comes from Sydney Grammar, last question in the 2023 paper. Really nice question in the topic now. Different schools call this this topic different things. I call it rates of change. Some schools call it applications of calculus. Some schools just call it motion and rates, right? So, but it's to do with motion along a straight line. Nice little question. Not as straightforward as you would think, but yeah, I thought it's a nice question. So, but before I begin, as always, if you haven't already done so, please subscribe to the channel, tell your friends, and like the video. Guys, let's dive right in. So, Sydney Grammar 2023. Let's see. So, 5 marks. Bo Katan. Bo Caton and Din are racing in their jetpacks with their jetpacks. 2 kilometer linear course, right, along a straight line. Bo Caton accelerates, right? Accelerates at a constant 10 meters per second squared with top speed of 35. So basically, accelerates now, does it say? I'm assuming they're starting from standstill, right? It doesn't really say. Yep. Okay, let's just assume that. So start from 0, accelerates to 35 meters per second, and then maintains that speed till the finish. That's what it says. Din. Maybe I'll use different color for din. Din accelerates, constant speed of 8, and then to 40, and then, okay, cool. So it looks like Din probably goes faster because the question actually says, due to a technical malfunction, Din starts n seconds after BK, right? Given that they both start from rest, there it is, but start from rest, Din wins, right? Din wins. So basically, the green highlight there wins. What is the largest possible value for n, right? So n seconds after, okay, cool. That's the first question. And then suppose they start at the same time, same point, same time. So at the start, same time, and i.e. that n is 0, so no head start. What displacement would they meet? So basically, at what displacement, at what x value will Din meet BK before overtaking? So I'm assuming they start, so yeah, and they do, right? Accelerate at 8, and then, but because the green Din accelerates for longer, eventually he'll overtake. So nice little question. Now, there's 2 ways to do this, right? Part A, there is a algebraic, right, calculus method where you basically go acceleration is blah, and then you got to do it. But you just got to be careful because when you integrate it, right, there's a cap because so for example, for the blue, if you say a equals to 10, and when you integrate it and go 10t plus c plus c1 or whatever, you got to set a boundary for that because that only exists for a certain amount of time, because once you hit top speed of 35, it stays at 35, right? So there's a calculus way. I'm going to show you the graphical way. I like the graphical way because A, it's faster, and B, it's just more intuitive, right? And I'll show you what I mean. So for part A, right? Now, and I'll also like to show the graphical method because it's really nice to relate a velocity time graph to how to get displacement from the graph, right? So the way you sort of see it, right, is in terms of speed, right? Let's plot speed on this, right? So this is the this is BK, right? Yep. So she starts from a velocity of 0, and then she basically accelerates till she hits 35 kilometers an hour, right? So this is velocity, right? And this is time. Now, so obviously, there's a certain time that she accelerates until she hits a certain point and then stays flat thereafter. Is that okay? Now, we can easily find what this time value is because I know that she accelerates at 10 meters per second squared, right? 10 meters per second squared. So basically, so if you take now speed equals the distance over time, so acceleration equals the distance. So acceleration equals to velocity over time, right? Yep. So basically, she accelerates at 10, right? And I want her to hit 35 kilometers an hour? No, meters per second. Meters per second after t. So then that t will be 35 on 10. So after 3.5 seconds, right, this here, 3.5 seconds, she'll hit 35 meters per second and then stay constant thereafter. Now, that's my graph. This is important because, right, what am I trying to do, by the way, for part A? I'm trying to find almost, if I can find the time that it takes BK to finish and then the time it takes DIN to finish, the difference will be the head start that's required so that they finish at the same time, right? That's what it's saying. Yeah. Also, not finish at the same time. That's the maximum, right? The maximum head start that she can give him, right? So what that means is that somewhere here, right, is the end of the race, right? And this is the value that I need, right? So maybe call this T1. Yep. Let's call this T1. Yep. For now, what do I want? So how do you find, if this is a velocity graph, how do you find displacement? Guys, it's all to do with the area under the curve. Yeah? The area under the curve gives you total displacement. Because if you think about it, when I integrate velocity, that gives me displacement. Integral is found when you find the area under the curve, right? So it all sort of hangs together, right? So now, finding the area of this is pretty straightforward because this area here, right, I can just use area of a triangle. Yeah, that there is a half times base times height. And if you punch it in the calculator, I think it's 61.25. Right, that's pretty easy. Well, you know what? Might move that bit over. And I might move this a bit down. Yep, just so I can have a little bit of space to work with this bit here. So that's that area here. And then this rectangle. Yeah. Now, I don't know what the value is, but I know that total area is displacement and the distance that I want to travel is 2 kilometers, right? So once I find an expression here in terms of T1, I'll then make that equal to, I'll make that equal to 2,000, right? When I add them together. So this one here is just rectangle. So it'd be like what? T1 minus 3.5 times 35, right? Whatever that is. So therefore, right, using, because I know total distance is 2 kilometers, right? So I go 61.25 plus 35 outside of T1 minus 3.5. That equals to 2,000 meters, right? That's just solving a really simplistic equation, guys. Just going to quickly whip that up. So 2,000 minus 61.25 and then plus 3.5 times 35. Is that right? Why do I feel like... I think that's right. I think that's right. So I'm just looking at the mess. I divide that by 35. Wait a second. That's no, that was right. That's right. Yeah, perfect. 58. Did you guys do this, please? Yeah, don't trust me. Right. My calculator skills is very low these days. 58.89 seconds, right? That's T1. Piece of cake. Guys, that is the time it takes for BK to finish, right? So, right, because we're now going to do exactly the same thing for DIN, and I'm hoping that DIN takes a shorter distance because he should go faster, right? And then the difference in the time is what the question's asking for. So same question now, or sorry, same approach, right? So whip up the velocity time graph for DIN, which is supposed to travel faster. So I think he accelerates for longer. Is that right? So let's actually work out. So acceleration equals V on T. So accelerates slower, but for longer. So velocity is 40 over T. So T is 40 on 8. So 5. Yep. So 5 seconds. So even though it's not as steep, right, he just goes for longer. And I know that there is 40 kilometers an hour, and this is 5. And guys, in the same vein, right, I've got two area, one rectangle, one triangle, and let's call this what, T2? Yeah, T2, and I'm gonna find the time. So I'm gonna find the time by equating the two area to the 2 kilometers traveled, right? So to do this area here is a half base times height. That's 8 times 5. What's that, 40? That's a lie. No, that's 20. 100? 100. Yeah, nice. And this guy here would be T2 minus 5 times 40. Yeah, guys, set that now equal to 100 plus 40 outside of T2 minus 5 equals to 2,000 meters. And then quite simply, so on your calculator, 2,000 minus 100 divided by 40 plus 5, 52.5, which is nice. So which is good because it's smaller than the other one because it takes less time because it's faster, right? So therefore, yeah, N would equal to the difference, which is a maximum head start that green can give blue, 892 minus 52.5. So therefore, N equals to 6.892 seconds. How's that? Yeah, piece of cake. Guys, pretty straightforward. Nothing too hard about that. That was part A. I like this method. Now, like I said, challenge yourself maybe, right? Challenge yourself to do the algebraic calculus way where you go A equals to 10 and A equals to 8 for the blue and the green, and then use integration, right? Just be careful though, because you probably need to do a piecemeal function for the velocity and displacement because at 3.5 meters, you can see from the graph, right? The velocity is linear, upward sloping for the blue for between 0 and 3.5, and then it's flat at 35 when time is greater than 3.5. So you just got to take that into account when you do it. Right? B. So suppose they start in the same place. What displacement? So you basically want. So the way you sort of see this, right? So I'll use a pink pen to demonstrate. Basically, there might be a time there, there, yeah, where the area is equal, right? So let me set that to t, right? So for part B, I'm just gonna find an expression for the area up until that pink point on blue. For the green, find the area up until the pink point there, and then send them together and then solve for t. That's the time when they would meet, right? And then once I find t, I just need to sub that into either expression to find x, right? Pretty straightforward, guys. Let's do it. So for part B, I'll just do it up here, right? So for the blue, yeah, so maybe I'll go blue, the area equals to, now I already have it down here, right? So it's basically taking this bit here, yeah, just an expression for the area. So, you know what? I don't even need blue then. Here's what I'll do, right? So set the blue area, which is that. Yeah, I'm gonna cheat a little. I'm just gonna copy and paste. And then I'm gonna sneakily rub off the T1, put pink T, and then set that equal to the area of the green, which right now, ungroup, get this guy. Ooh. It didn't ungroup. No, it's just not letting me highlight for some reason. Yep, set that. Ooh. Equal signs coming for the ride. Okay. Okay, and then I'm just gonna scroll over, zoom in. All right, so let me delete this as well, and then set that to pink, and then make them equal. So just to be absolutely clear, that's the area on the blue, and that's the area of the green, right? When they're equal, that's when the displacements will be equal at a future point in time. And now all I got to do, solve for t. Once you get t, sub it into either the blue or the green to get the displacement, right? So guys, solving that now, I trust your ability to do this equation, right? If you did it right, I believe the answer is 7.75 seconds. And then really all you need to do is plug this answer into either stream, because they're equal, right? Into either stream. Plug it there. So therefore, actually not. That one's got more decimals. I'm going to be smart and plug it in this side. Yeah. Just be smart. Therefore. All right. Displacement equals to 100 plus 40 times 7.75 minus 5. Yeah. Punch in the calculator, 210 meters. How's that? So I thought this was a really good question for us to explore using the graphical method, which is the graph which has velocity over time, because then by that we can draw out displacement by using area. Right, guys, if you like that video, please, as always, like the video, subscribe to the channel, and tell your friends. Thank you very much.